Good morning, students. Today we'll discuss SAQs from laws of motion. Yesterday I gave few SAQs from motion in a plane. Now our next SAQ from laws of motion. Pulling is better than pushing. Pulling is better than pushing in the case of lawn roller. So in examination, they're asking why a lawn roller preferred. Pulling is better than in the case of pushing. In the case of lawn roller, always we preferred pulling compared with pushing. What is the reason for that one? This one, diagrammatical explanation, lawn roller. Lawn roller means, for example, you are watching cricket match, suddenly rain coming. After rain, one roller moving on the ground. It removes water from ground. Lawn roller. Pulling is better than pushing. First, our explanation about pulling. One more case, pushing. This is the diagram, lawn roller wheel. mg, weight. Nothing but gravitational pull. mg downwards. Normal reaction upwards. Our topic in the case of lawn roller, pulling is better than pushing. Always normal reaction upwards, mg downwards. Pulling and pushing, special concentrate on external force direction. This is capital F, pull. This is pull, like this, arrow mark towards, arrow mark here, outside there. So pulling and one more pushing, student. First our topic about pulling. Here F divided into two components. One is the cos component horizontal. Next one is the sin component. Pulling is better than pushing. N normal reaction upwards, mg downwards. Capital F is the external force divided into two components. Always horizontal component is the F cos theta. Vertical component F sin theta. F external force, arrow mark out, outside the center. This one only pulling. Now sum of upward force equals to sum of downward force. F upwards, N plus F sin theta. Downward force, mg. From this one, what is the normal reaction formula? mg minus F sin theta. This is normal reaction. Normal reaction. So frictional force F equals to mu into N. What is the general frictional force means? Small f is the frictional force. Capital F is the external force. F directly proportional to normal reaction. On removing directly proportional, we can get constant mu. So F equals to mu into N. Substitute N formula, we can get our frictional force. Mu into N, mg minus F sin theta. Equation number 1. This is the frictional force in pulling. Our topic about pulling is better than pushing in the case of lawn roller. One diagram pulling, F is the external force divided into two components. Normal reaction here upwards, mg downwards. One is action, one is reaction. F divided into two components. One is the sine theta, second one is the cos theta. So we are writing sum of upward force equals to sum of downward force. Upward force means N plus F sine theta. Downward force means mg plus F sine theta going right side minus normal reaction N equals to mg minus F sine theta. This is the normal reaction. Now what is the frictional force means? F equals to mu into N. Mu into N mg minus F sine theta. Equation number 1. This is frictional force in the case of pulling. Next student, pushing. See. Again diagram. Same lawn roller on horizontal surface. Mg downwards. Normal reaction upwards. Pushing like this. Capital F. This is pushing. This is pulling. Capital F divided into two components, students. One is the F cos theta. Next one is the F sin theta. Previous case mgn, present case mgn, both are same. What the reason means? Normal reaction always balances with weight. Upward direction there. Gravitational pull always acting toward the center of the earth. So arrow mark different. F sin theta downwards, N and this two. Total sum of upward force equals to sum of downward force. Again, we are going on same point, student. Upward force nothing but N. Downward force nothing but F sin theta plus mg. This is normal reaction. In previous case also we got normal reaction. What is the frictional force means? Mu into N, mu into mg plus F sin theta. Equation number 2. So present equation we got plus. Previous equation we got minus. Mg minus. Which one highest force means? This one highest force. That's why from equation 1 and 2, where least force we are applying in previous case. That's why we are writing from 1 and 2, pulling better. This is the lawn roller question, student. 3-star question, most important for upcoming supplementary examination. First question, why pulling is preferred than pushing in the case of lawn roller? We are writing heading, pulling is better than pushing in the case of lawn roller. First diagram from lawn roller side, pulling case. This is the lawn roller wheel, normal reaction and mg. Normal reaction upwards, mg downward, that one fixed. F out, pulling. Second case, F in, pushing. Normal reaction mg. Now next, sum of upward force equals to sum of downward force. What the upward force means? N and F divided two components. F sin theta plus N. This one upward force. Downward force is equal to mg. Then frictional force formula, F equals to mu into N. Frictional force mu into N. What is the 1 minute? Here. What is the N concept means, student? From previous this step, mu into mg minus F sin theta. This is the equation number 1 in the case of pulling. Now in the case of pushing, sum of upward force is equal to sum of downward force. Here, normal reaction upwards, mg downwards. Same situation from previous case also. Pushing, external force F. This is push. This is pull. Arrow mark different. Quite opposite, student. F divided into two component. Normal reaction upwards. Mg plus F sin theta downward. Sum of upward force is equal to sum of downward force. Based on that point, we are going. F equals to mu into N. N stands for normal reaction. Mg plus F sin theta. Overall, from equation 1 and 2, pulling is better because we are getting in pushing plus, pulling means minus. Okay. This question, same as usual, like previous question model only, student. I am giving in short way. This one only actually short. Compare that one, more short method we are getting. So, pulling is greater than pushing in the case of lawn roller. See here, student. See here, lawn roller. See here. Don't think this is the difference. This is the short method, brief explanation. You take one is the pulling. Next one, pushing. See here, mg, n. Here you keep same. N, mg, cos theta term, student. Pull. Take like this. Theta, F divided into two component. F sin theta. Pulling means upward coming, student. What about pushing? Theta. F cos theta. F sin theta. This one diagram. For diagram, you can get here 1 mark, here 1 mark. Total 4 marks question. You are getting 2 marks from 2 diagrams. Arrow mark most important. Then after, upward force equals to downward force. Then what is the normal reaction formula? Mg minus F sin theta. Frictional force mu into N equals to small f equals to mu into mg minus F sin theta. Equation 1. Here, upward force equals to downward force. Same concept we are going. Frictional force means mu N. F equals to mu into mg plus F sin theta. Therefore, from 1 and 2, pulling better. This lawn roll explanation, previous explanation, 100% same. You can get full mark, student, 4 marks. Previous case, like this diagram, just somewhat explanation. Present case, one side pulling, one side pushing. Normal reaction, frictional force, frictional force. Here 1 mark, here 1 mark, here 1 mark, here 1 mark. Total 4 marks you are getting from this 4 steps. Okay, that's why pulling is better than pushing in the case of lawn roller. This is the 3-star question from laws of motion. Okay, now we'll discuss next question. Method of decrease friction. Method of decrease friction. Sometimes they're asking reducing methods of friction. Sometimes they're asking decreasing methods of friction. Sometimes they're asking what is friction, how it is reduced, like the different ways, 3 different ways, answer same. What is the actual question according to our textbook? Means method of decreased friction. For this method of decreased friction, total 4 methods. What the reason? Means 1 method, 1 mark, one side heading with explanation, one side heading with explanation, like that. 4 side headings. Highlight on side heading. Just this question came in examination. You write side headings with small point. First of all, I will give you complete explanation. Method of decreasing friction, polishing method, next lubricants, ball bearings, streamlining. Total 4 side heading. Student, listen carefully. Remember, they can get shocked after this answer. See, polishing, side heading. By using polish, otherwise on polishing, friction reduces. By using lubricants, friction reduces. By using ball bearings, friction reduces. By using streamlining shape, friction reduces. Just side heading is important. When you are writing this answer, concentrate on side heading. For 4 side headings, you can get 4 marks. Polishing, what you are writing? On polishing, friction reduces. You know, in our house, marbles, tiles, all this one, polishing only. Polished stones. Lubricants, you know, grease, oil, water sometimes. Ball bearings, ball bearing mean like this, you know, everyone. Steel balls are placed inside the ball bearings. So rolling friction coming here. You are not going that much depth. Side headings only. Streamlining shape means just concentrate on bullet train. So this is the bullet train shape. This one streamlining shape. Otherwise, daily life you observe auto like this coming curve shape. All this one curve shape, student, streamlining shape. You don't write auto, ball bearing, train like this. Just you need 4 marks. How? 4 side headings. On polishing, friction reduces. By using lubricants, friction reduces. By using ball bearings, friction reduces. By using streamlining shape, friction reduces. In automobiles, vehicles, streamlining shape nothing but curved shape, student. So 4 methods there for reducing friction or decreasing friction. This one 4 side headings. This question, previous question, individual 4 marks question. Very simple and easy answer, this one. Of course, lawn roller case also very easy. This all questions from laws of motion, more questions there. First of all, here again I'm coming from lawn roller onwards. Lawn roller means go this method. Pulling is better than pushing in the case of lawn roller. First diagram for pulling. One more diagram for pushing. Pulling, pushing means anytime they're writing means, if you remember, they can get confused about this arrow mark, students. Normal reaction upwards, mg downwards. Normal reaction upwards, mg downwards. F external force, pulling means up, pushing means in. When you are reading this lawn roller question, special concentrate on diagram. In diagram only everything, every answer, every step they are getting from diagram. So F sin theta, F cos theta. F is the force, is a vector quantity divided into 2 components. One is the F sin theta, next one is the F cos theta. Upward force equals to downward force. We got equation number 1. Again, upward force is equals to downward force. We got equation number 2. One is positive answer coming, one is negative answer. Equations obviously minus least. That's why from 1 and 2 pulling better. This is the case lawn roller. One more, decreasing methods of friction, reducing methods of friction. 4 marks question, 4 side heading, 4 schema of evolution point. First point, polishing. You write order, disorder. In this one, no order. You write any 4 points. Your choice. First one, member writing with streamlining. No problem. Polishing. By using polishing, friction reduces. By using lubricant, friction reduces. By using ball bearings, friction reduces. By using streamlining shape, friction reduces. Total 4 methods there to reduce friction. So this is the second question, second SAQ for this day. Next, student, see, few problems we'll do. See here, from NCRT come Telugu book, we are doing problem. What is the problem means? 1 minute, wait. Motion in a straight line case only problem. See, student, this problem, multi-story building, page number 49, example 3.4, page number 49 from Telugu Academy book. Motion in a straight line is the lesson. Example number 3.4. This question, 3-star question, multi-story building. Now listen, student. In this one, different method they gave. We are going short way. First of all, question. What is the data? A ball is thrown vertically upwards. A ball is thrown vertically upwards with a velocity of 20 meters per second from the top of a multi-story building. One multi-story building. So this is the building, multi-story building like this there. A body thrown upwards. This is the ground. How much? U equals to 20 meters per second. Multi-story building means first floor, second floor, like that, different floors. A ball is thrown vertically upwards with a velocity of 20 meters per second from the top of a multi-story building. So, a ball thrown 20 meters per second from the building upwards. The height of the point from where the ball is thrown is 25 meters from the ground. Here, ball is thrown, this point of projection to ground, 25 meters. Indirectly, they are giving height of the building. So, the height of the point from where the ball is thrown is 25 meters from the ground. How high will the ball rise? Meaning, how much height ball will be going? How much height ball will be raised? First, a ball thrown from top of the multi-story building with how much velocity? 20 meters per second. So, student, H equals to question mark. How much height the ball will be raised? Like this. H equals to question mark. And what is the building height they gave? 25 meters. How high will the ball rise? Question number 1. Second one, how long will it be before the ball hits the ground? Meaning, how many seconds required for ball to reach ground? Second one, time. First one, maximum height. Total 2 questions, student. Here they give different method. Compare that one. This is the very easy method I am giving here. Easy method with known formulas. First of all, question number 1. How much height? You know very well about what the maximum height cases in the case of vertically projected body. H equals to U square by 2G formula. H equals to U. How much height? 20 into 20 by 2 into what is the acceleration due to gravity? Approximately value 10 meters per second square. 10. 2 into 10, 20, 20 cancel each other, 20 meter. So how much high the ball will be raised means 20 meter. This is the problem number 1 for this one. How much height it will be raised means 20 meter. Second one is there. What is the time taken by the ball to reach ground? Now see, second one, H equals to half GT square minus UT. This is the formula for height when a body thrown from certain height, from cliff, from building, height formula. How we are getting, just explanation, you listen. How we are writing H formula means, you know, S equals to UT plus half AT square. This is the equation of motion, student. Now see, S meaning displacement. Now see, all member, listen carefully. From here to here, again here, see. What is the displacement means? One minute. Here, S equals to UT plus half AT square means, student, this is the height. But our topic about S, not height, displacement. Body going like this. Example, from year to year up, from year to year down, numerically cancel each other. This is nothing but displacement. So from here to here means this is the height. Here we are taking sign convention from this point to this point means that's why we are taking S equals to minus H. That one displacement, student. Don't think height. So S nothing but minus H, displacement traveled by the ball. S equals to minus H. This explanation for how we are writing H is equal to half GT square minus UT. And what about A? Body moving upwards means minus G. Substitute. UT plus half. A means minus G. UT plus into minus minus half GT square. Minus multiply both sides. We are getting half GT square minus UT. Overall, what is the displacement formula in the case of building means half GT square minus UT. Now height, nothing but displacement only case, student. H equals to 25 meter. G equals to, obviously we know, 10. 10 is the approximate value. Now T equals to question mark. H 25 half G T square minus U. Initial velocity 20 into T. We can get quadratic equation 2 1 ja 2 5 ja. 5T square minus 20T plus coming left side means minus. So 5 you take common. T square 40 5 equals to 0. This 5 coming right side means obviously 0. T square minus 40 minus 5. T square minus 40 minus 5. We are going quadratic equation method, student. 5 1 ja. T minus 5. So T minus 5 equals to 0. T equals to 5 seconds. What is the time taken by the body to reach ground means 5 seconds. Why we are not taking plus 1 means answer we can get minus. Time always positive only. One more time, listen, student. Question they gave, this is the example problem from motion in a straight line, multi-story building, a ball thrown from a multi-story building with how much velocity? 20 meter per second. Point of projection to ground 25. What is the question? Total 2 questions they are asking. how much high the ball will be raised, and what is the time taken by the body to reach ground. One is the small t equals to question mark. Second one, what is the height, maximum height from building, point of projection. H equals to u square by 2g. U value they gave 20. U square meaning 20 into 20 by 2g means 20 coming, 20 cancel. Total from building, it rise up to 20 meter. Then after a ball thrown from multi-store building, what the H formula, displacement formula means H equals to half gt square minus ut. H meaning 25, half g value 10, t square. Overall, we can get t square minus 40 minus 5 from this one quadratic equation. We can get 5 seconds. This is the multi-story building. Total two special cases there. One is the how much height ball raised. Second one, what is the time taken by the ball to reach ground. Most important problem for SAQ. Okay. Say now students here today up to now 3 SAQs over. One, pulling is better than pushing in the case of lawn roller. Second one is method of decrease friction. Third one, multi-story building. Up to now, finished SAQs, just 1 minute I am writing on board, special focus on board. Then after we are going towards one more SAQ. Parallelogram law. S equals to ut plus half at square, graph method. Next, path of the projectile, parabola. Next, H max comma range. Prove equations. Next, lawn roller. Pulling is better than pushing in the case of lawn roller. Next, method of decrease friction. So students, these are the questions. Next, problems. A car moving with three different 18 kmph came. Yesterday problem. Next, show that H max equals to 1/4 of range. Theta equals to 45 degrees. Next, multi-story building. Students, up to now, finished SAQs. One is the parallelogram law. Next one, S equals to ut plus half at square, graph method. Path of the projectile, parabola. H max range, define maximum height range. Prove its equations. Pulling is better than pushing in the case of lawn roller. Method of decrease friction. A car problem, 1/3 of distance 10, 2/3 distance 20, last third with 60. Yesterday problem. And yesterday case only this one. If theta equals to 45 degree, H max equals to 1/4 of range. Next, multi-story building. These 3 problem zone and these 6 questions. From this total 6 plus 3, 9, minimum 3. Half of the SAQs you are getting from this one only. Half of the SAQs for upcoming supplementary examination you can get from these questions. Okay. So these are all motion in a straight line with plane. Few questions from laws of motion student and one more LAQs. This one 3. You need 6. You need 6 SAQs, 3 from this one only. Minimum 3. Other than rough critical situation, 2 compulsory. 300%. Other than this one, long answers. Say, then after we are going towards next 4 marks question. Say, like this. First law of conservation of energy, freely falling body with bullet problem. Define work kinetic energy, work energy theorem. For this problem, for this question, you are doing 2 problems. 2 problems, power of motor. One is the 15,000 watts, 15 kilowatts. Next one, 170 HP. Otherwise, 166, no problem. Next, define SHM. Particle motion SHM with respect to diameter. Fixed problem, phase angle 5/4 radians. Next, time period of simple pendulum 2 pi under root of L by G. For this one, 3 special cases, student. One is ticks. Next one, length of pendulum. Length of pendulum, 1 meter. Next, 7/16 meter decreased. That is the problem. From this to 1, extra safe side you are going Newton law of cooling with surrounding temperature. Surrounding temperature 28.3 degrees Celsius. Last question from thermodynamics. Reversible, irreversible process, Carnot engine. So, these 6 previous SAQs, day 1 onwards, I explained this total 6 LAQs. Every student, remember, you read 6. For example, one student unable to read 6 questions. I will give clue. From this total 3 sets, you select any 2 sets. 2 sets means 2 questions, student. For example, one student going 19th and 20. Any 1 question you read from other set. For example, one member going 20 and 21, 2 sets reading. In this one. Meaning, you read any 5 from this total 6. Pakka, you are getting 2 LAQs for this supplementary examination. These are the LAQs, and up to now, finished SAQs, this one. Parallelogram law, S equals to UT plus half AT square, maximum height range, lawn roller, method of decreased friction, and right side problems. From this one, 3 coming. Now listen. See, student. Now, from gravitation, we are going zigzag. From gravitation, escape velocity, orbital velocity. Last time they gave orbital velocity. So, one is the escape velocity, one is the orbital velocity, one is the geostationary satellite. With one more question is there, Kepler laws of planetary motion. From this 4, you can get 1 question. Gravitation lesson belongs to 4 marks. Work power energy related to 8 marks. Oscillations 8 marks. Total 3 lessons, 8 marks question coming. One is the work power energy. This is the 8 marks LAQ. LAQ from work power energy. oscillations. This one also 8 mark. One more, thermal properties of matter. Overall heat lesson I am writing. Thermodynamics. From this one, yeah, total 3 LAQs coming from 3 different zone. Work power energy 1 LAQ, oscillation 1 LAQ, thermal properties of matter with thermodynamics, you are getting 1 LAQ. Total 3 long answers from 3 different zone. Work power energy, oscillation, thermal properties of matter with thermodynamics. Here 2 questions, that 19th bit. Here 2 questions, 20th bit. Here 21. This is Newton law of cooling. Thermodynamics means reversible, irreversible process, Carnot engine. So, special focus on this long answer lessons. These are the long answer 3 lessons, student. All these SAQs, this is from plane, this is from straight line. In straight line, more 3 conceptual questions present. I will give explanation. This one from motion in a plane, this one plane, last 2 from laws of motion. This is from straight line, this is from straight line, this is from straight line. All these 3 problems from motion in a straight line. Okay. Here, in previous, last time you wrote annual examination. In annual examination, 1 question came. What is the question means? Modulus of A plus B. Modulus of A plus B equals to modulus of A minus B. A plus B equals to A minus B. What is the angle in between AB? Sometimes a repeated question coming, student. This one very easy problem. Modulus of A plus B equals to modulus of A minus B. When I am teaching parallelogram law, I said A plus B whole square equals to A square plus B square plus 2AB. Mathematically, you are going A square plus B square plus 2AB. In physics, that parallelogram law concept, we can get A square plus B square plus 2AB cos theta. Square going right side, root. Extra cos component coming from horizontal axis, A square plus B square plus 2AB cos theta. Why we are writing this one means that one, this one 100% same. A plus B. For example, you write A minus B whole square. A minus B whole square meaning A square plus B square minus 2AB. You take here A minus B meaning under root of A square plus B square minus 2AB cos theta. Why we are getting cos theta means vector resolution, x-axis horizontal nothing but cos theta, vertical nothing but sin theta. So modulus of A plus B equals to modulus of A minus B. What is the angle in between AB? Recent, this question you got in annual examination, student. One more time check. Very easy problem, simple. Modulus of A plus B is equal to modulus of A minus B. So what is the angle? Squaring on both sides. Squaring on both sides. We can get A plus B whole square equals to A minus B whole square. A square plus B square plus 2AB cos theta. Right side, A square plus B square minus 2AB cos theta. Here, A square B square cancel each other. Minus coming left side, 2AB cos theta plus 2AB cos theta equals to 0. 4AB cos theta equals to 0. cos theta equals to 0. This is 0. Don't think 0 degree. Cos theta equals to 0 means theta equals to 90 degrees because cos 90 equals to 0. Cos theta is equal to 0 means for which cos angle we can get 0 meaning 90. So modulus of a plus b is equal to modulus of a minus b. What is the angle in between AB means 90 degrees. Find angle in between A and B. First, modulus of A plus B is equal to modulus of A minus B. Squaring on both sides. A plus B whole square equals to A minus B whole square. In parallelogram case, we are going A square plus B square plus 2AB. In parallelogram law, IP version P plus Q there. IP version means sum. See, like this. R equals to P plus Q. This is the sum. Nothing but P square plus Q square plus 2PQ cos theta. What is the in object version? One more is there. Difference. One is the sum, one is the difference. P square plus Q square minus 2PQ cos theta. One is the sum, one is the difference. So, student, P square plus Q square plus 2PQ cos theta is the sum. The difference. Same method we are going. Root left side square, right like this. That one only, this one. So, A plus B whole square equals to A minus B whole square. A square plus B square plus 2AB cos theta. Right side, A square plus B square minus 2AB cos theta. Two terms cancel each other. 4AB cos theta equals to 0. Then what is the overall angle? Theta equals to 90 degrees. This question you got in recent examination, recent annual examination you finished. In that one, 11th question, this one only student, modulus of A plus B equals to modulus of A minus B. 99% it won't come. Sometimes repeated question coming. That's why you focus on this one. A plus B equals to A minus B. What is the angle? 90 degrees. A comma B, both are right angles to each other. Okay. So, these are the finished questions. One more question I will give, conceptual question. First 8 marks means these three. I am giving clear-cut explanation, student. These are the 8 marks. This is the 8 marks individual questions what you are reading. Again, I am repeating. Select any 2 sections. One more section, one section you are leaving now. In that one, you read any one. Meaning, one student, minimum, one student reading 5 LAQs. So, you are reading minimum 5, maximum 6 for this supplementary examination. And these are the 4 marks question. When I am finishing total 4 marks, I will give you 4 marks explanation also. Up to now, finished SAQ student, all this one, 3-star questions. Car maximum height equals to 1/4 of range, multi-story building. All this one problems from motion in a straight line. In motion in a straight line, one question. What is the question means? Can, otherwise I will read from book direct. Page number with questions here, student. Here, student, page number 57, question number 3. All this question looking like VSAQs, but in examination you can get all these questions for 4 marks question, SAQs. Can the velocity of an object be in a direction other than the direction of acceleration. The direction of velocity is other than direction of acceleration of the object. This is possible or not? If so, give an example. What is the question they're asking means the direction of velocity is other than the direction of velocity of other than the direction of acceleration. Simple. Velocity, acceleration, both are in different direction, opposite direction. Possible or not? If possible, give example. One example, student. Remember, they are reading two. That is your safe study. You are reading one example. What is the question? See, for this question, answer starts from yes word onwards. Is other than the direction of acceleration. This is the question, student. Velocity direction, acceleration direction, both are different. Other than, meaning answer starts from yes. Answer only yes onwards, meaning direction of velocity and direction of acceleration, both are in different. Possible. Yes. Example number one. Example one enough, student. Because give an example. They're not asking to. Give an example means very simple example. Just project a body. A body projected upwards. Obviously, body going upwards. What is the velocity direction? Upwards. What is the acceleration due to gravity direction? Downwards. Meaning, this is the body, a body projected upwards. A body projected upwards means acceleration and velocity both are in different direction. For example, take Diwal rocket. What is the Diwal rocket means here like this? Here we are keeping fire. Then this Diwal rocket going upwards. Like this, they're going upwards, upwards, upwards. After some time, after few minutes gap, again it comes down. After explosion, this one comes down. This one, Diwal rocket, student, don't think our daily life rocket, ISRO rocket. ISRO rocket means always it maintains constant speed. Why this rocket again coming towards ground means you know about gravity. Same example, velocity of object other than the direction of acceleration means in the case of vertically projected body, velocity of the body acting upward direction, velocity acting upwards, acceleration due to gravity downwards. Both are quite opposite. Acceleration due to gravity. One more example to take. Yesterday concept projectile like this. Projectile going there. Here. This is acceleration due to gravity. This is the velocity x component there, student, velocity y. Meaning velocity acting tangentially, acceleration due to gravity acting downwards. In the case of simple pendulum, like this, see, this is the velocity direction. Acceleration always with respect to its mean position. So all these examples belongs to velocity and acceleration, both are in different direction. That's why I'm giving example from motion in a straight line, because this question from motion in a straight line, that's why we are selecting example from this lesson only. In the case of vertically projected body, Direction of velocity is upwards, but acceleration due to gravity acting downwards. This is the example for this question. Answer starts with yes onwards. For this S also 1 mark is there. 1 mark here, 3 marks here, total 4. This answer looking like VSAQ, but in examination you are getting in SAQ zone. Then the velocity of an object is other than the direction of acceleration. Yes, it is possible. Answer. Example. Okay, student. So these are all motion in a straight line. Tomorrow we'll discuss other SAQs. Up to now, 6 LAQs you are reading and minimum 3 SAQs. Tomorrow we are going towards gravity.